Well, hi there, boys and girls. Today we're going to talk about concavity, or what does the second derivative say about f. We're going to have a definition of concave up. If f prime is increasing on an interval, then we are going to say that f is concave up. And if f prime is decreasing on an interval, then we're going to say that f is concave down. Now, how do we tell if something is increasing or decreasing? How do I know if f prime is going up or going down? Well, that will be from the second derivative. F double prime will tell me whether or not f prime is increasing or decreasing. So if f double prime is positive for all x in an interval, then the graph of f is concave up. And then if f double prime is negative for all x in the interval, then the graph of f is concave down. That's how we're going to tell. So that's going to also bring us to an inflection point. Wherever we change concavity, we're going to define that as a point of inflection. A function f is going to have an inflection point if f double prime equals 0, or if f double prime does not exist, DNE, and on top of that we have to change sign. So if f double prime changes sign from negative to positive, or positive to negative, or if f prime changes from increasing to decreasing, or vice versa, decreasing to increasing, then we're going to say that we have a point of inflection at that point. Let's take a look at this graph and see if we can figure out the signs of f prime and f double prime on the interval from 0 to 3. So we need to see, are we dealing with a positive or are we dealing with negative values? First of all, this is f, so f prime would be the slopes to this graph. So let's just draw a couple little baby tangent lines here. What kind of slopes do we have here? Well, I can tell that f is decreasing. And if f is decreasing, that means that f prime is definitely negative. So f prime is negative, but what's happening to f prime? Is f prime getting bigger or smaller? This is a pretty steep negative out here, but it looks like that f prime is slowly getting larger and heading towards 0. So since f prime is increasing, even though they're all negative, they're not as big negatives. Since f prime is increasing, that means that f double prime is going to be positive on that interval. This is a concave up graph. It's part of a smile. It makes me happy. All right, so let's throw all this together. We have to take this function and we've got to find all of this business, increasing, decreasing, relative extrema, and we're going to add to this concave up and down and inflection points. So what I'm going to do is I'm going to take the first derivative and do the first derivative test. We've already done that before. So I'm going to take the first derivative up here. So f prime is going to equal 4x cubed minus 12x squared. And we're going to set that equal to 0, so I'm going to factor this out. I'm going to get out, I guess I can take out a 4x squared, which is going to leave me with x minus 3. Does that look right? 4x squared, 4x cubed. Yep, that looks right to me. And we want to set this equal to 0. That's going to happen when x equals 3 and when x equals 0 because of the 4x squared. These are critical points. They're critical points on the graph of f, so they are potentially a max and a min. So let's do our first derivative test. I'll draw my number line there and go back to my pretty purple pen. And I'm going to put 0, my critical point on that number line, and also 3. Now we're checking f prime so that we can figure out some things about f. So I'm going to plug in a number like, say, negative 1 into my factored form of my derivative. So negative 1 minus 3 would be negative 4, and negative 1 squared is positive. I'm going to have a positive times a negative. So since f prime, come on, positive times a negative is a negative. So if f prime is negative, that means that f is decreasing. Now let's plug in a number like 1 between 0 and 3. 1 minus 3 would be negative 2 times a positive. Well, that's also negative. So I'm still decreasing. And then after 3, like 4, if I plug 4 into my derivative, I'm going to get a positive times a positive, and finally I get an increasing graph. So I'm going to make some statements here. I'm going to say that f is decreasing on the interval from negative infinity to 0, unioned with 0 to 3, because f prime was negative. And then I'm going to say that f is increasing on the interval from 3 to infinity because f prime was positive. And then on top of that, we have an extrema here. I've got a relative extrema at 3. F has a what? This is a relative something. Let's go take a look at, all right, has a relative blank. We went from decreasing to increasing, so you can sort of see that that's a minimum. If f prime changes sign from negative to positive, then f has a relative minimum at x equals 3 because f prime changed sign in a specific way. F prime changes from minus to plus. Okay, so that's all old stuff. Now we're going to do some concave up and concave down, and then we're going to see if we can try and sketch the graph. So I need to go to the second derivative. I'm now going to do the second derivative, which would be from f prime, that's going to be 12x squared minus 24x. And we want to factor that, so I'm going to pull out a 12x, which will leave me x minus, I believe that's 2. So that's going to equal 0 or undefined when x equals 0 and when x equals 2. This is what makes, these are critical points for f prime, I guess. Or they're critical points because f double prime was 0 or undefined. They're critical points for f double prime. All right, so these are potential points of inflection. So what I'm going to do is the number line test on f double prime. So let's do a little number line here and get back to my pretty little purple pen. And I'm going to do 0 and 2. Now what I'm doing is I'm trying to organize my thoughts for f double prime that should say something about f. So we're checking f double prime's sign. So let's plug in like -1. If I plug -1, I'm going to have a negative times a negative, which will be a positive. And if f double prime is positive, that means that f is concave up. It's part of a smile. Now if we plug in a 1, we're going to get 1 minus 2 is -1 times a positive. I'm going to have a negative second derivative, which means that f is concave down. And then at 2, let's plug in like 2.5 or 3. We're going to get a positive number on this side, so f is back to concave up. Now I have that's a weird statement. I now see 2 points of inflection. I'm going to say that f has points of inflection. We're going to abbreviate that as POI. F has a POI at x equals 0 and at x equals 2. Why? Because f double prime changed sign. So if f double prime changes sign, we're going to have a point of inflection. Now I'm going to erase all this because I'm going to try and graph this business from this information. So I'm going to erase all this, but I have it written down here next to me. So don't worry about me. I'll be okay. So we're going to erase. Okay, so let's see if Mr. G can come up with a graph here. Let's go back to a line. I guess I'll just use this right here as my axis. Okay, so my original graph, I'd like to know some zeros on my original graph. So if you set that equal to 0, if you factor out like an x cubed, you get x minus 4. So the original graph of f has zeros at 0 and also at 4. Now we also said that it had a relative minimum at 3, so I need to say something about 3. Something else happened at 0 and also at 2. We had a point of inflection change at 2 and at 0. And so let's see if we can just bring all this together. F was decreasing all the way to 0, but also concave up. So decreasing but concave up. Now at 0, I have to change my concavity. I have to change to be part of a frown. So I'm turn it around and be part of a frown there. That's not very good, but that's the best I can do on this little tablet. And then at 2, I'm going to change my concavity again. Let me pull this down. So I was concave up at, from 2 to infinity. I was only concave down from 0 to 2. See if I can do that there. This is not very good. I'm going to change it to concave up. I have a minimum at 3 and then a 0 back here at 4. That was a little hard to do on my little tablet, but here's a point of inflection, and then also right here at 2, that's also a point of inflection. Concave up, concave down, concave up the rest of the way. Have my minimum down here at 3. I guess that's sort of okay, but anyway. All right, so let's see if we can do 2 last sketches to end this. I want to have zeros at 0 and also at 2. That's what this statement says. We have a 0 at 0 and 2. I need f prime to be positive. That means I need to be increasing. F needs to be increasing to the left of 1. Then I need f prime of 1 equal to 0, so I'm going to have increasing to decreasing. That's going to create a relative max. And I need f double prime to always be negative. This means concave down. It has to be frowning the whole way. And that's going to be fairly easy for me to draw. I missed a 2. I missed. Imagine that I hit there. I missed. Anyway, that's concave down the entire way. And I'm increasing until I get to 1 and then decreasing after that, and I missed my point. So please forgive me. Let's try another one where f of 0 and f of 2 are both 0. I'm going to be increasing until I get to 1. Then I'm going to have a sharp turn or an undefined derivative. So I'm going to say a corner or a sharp turn. And then f prime is negative. That means I'm going to be decreasing. And f double prime is positive the entire way. I have to be concave up, or part of a smile. So let me show you how this will look. Concave up until I get to 1, and I'm going to do a sharp turn, and I'm still concave up until I get to 2. Hopefully you can sketch that better than I can on my little pad there. Anyway, so there's our sharp turn, concave up, increasing to decreasing. So you guys will practice points of inflection and concavity, and I will see you guys tomorrow.